Hello, students of Physics 32, and welcome to the new quarter. And somebody's yelling. And welcome to lab number 1. Okay, I'm going to do this pretty quickly, so let's see how it goes. So the first part of the lab is the gravitational potential energy lab. So you're going to start with the two objects touching at 0 radius, and then you're going to record in the table the gravitational force at that distance using the forces, the tab. Right. So using forces, you'll see that number. Okay. So you're going to then step up in 7 steps and record FG for each of those different distances, and just keep writing those down in the table. Delta R is half of a tick size value, and you're also going to calculate the error on 1 over r squared, delta 1 over r squared, as in the Google Doc. Turns out to be 2 delta r over r cubed. So then you're going to plot the force on the vertical axis versus 1 over r squared, and then you're going to find the slope of that and figure out g from that using, as we've done often, y equals mx, where y is fg, x is 1 over r squared, and then m is the slope. It's everything, g times m1, m2 in front of that, okay? You're going to put horizontal error bars, and you're going to see how close you get to g and see that you're in range. The second part of that, of number 1, is to take delta u equals g m1 m2 over r1 minus g m1 m2 over r2. Find that difference. That's the work it takes to go from one distance to the next distance, and then you're going to compare that versus to the work that the simulation tells you. Okay, see that you get similar values. That's it for that part. Part 2. You want to derive equation 3. The lab doesn't tell you, but everything in red in my Google Doc is stuff I do want you to do, and I will grade on. So you want to derive equation 3, that is Kepler's third law, using the just sort of exactly how I tell you in the Google Doc. You just walk right through it. Hold on.